Good morning.
Hello, good morning.
So, I hope the quality is good enough. If the quality of the audio is not good enough, please let me know.
Okay, but it's okay. I think
Good.
I better turn off the video also, maybe to improve it.
Okay, great. So, thanks for sharing your use case analysis.
You're welcome.
So, let's
And how
see.
was it? That you pointed out quite a few issues with it, and I just was reading them, and I realized, of course, every time I read the points, I was saying, of course. Yeah, I missed a lot of things.
It's work in progress usually.
Yeah, but I was thinking, how come? I was thinking a lot about the supervisor at the first exercise you gave me with the Bhopal stuff, and at
Yeah,
this point I totally ignored it, and I was surprised how I was able to ignore it this much.
it's okay.
Yeah.
It's okay. No worries. For me, it's more important that you get an idea what you should do in the master thesis, and that
Okay.
you find your way. Okay, because the interesting thing is there are several solution parts, but you
Mhm.
have to put them together in a new, unique way.
Okay. Okay.
And
Okay.
therefore, it's very important that you understand where do you want to go, because every time you will look at a solution part
Mhm.
that has been worked out by somebody else, it will look very convincing, but you have to understand what is helping you and what is detracting you from your path, right?
Yes. Yes. Correct. Correct.
Okay. And that's what I want to discuss with you today.
Okay.
Great. Let me step you through what I wrote, and you ask questions, and then I want you let's take an initial use case to think about where you could apply this, so we have something concrete to discuss if questions come up, right?
Okay. Okay.
So you have been working on the repository use case based on Valentin's work, I think, yeah.
Yeah.
But what you have to also think is that your work should be for improving business processes at TU Wien in general, right? It's not just
Yeah.
repository.
Yeah. 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 So
Good.
I need to think about how to properly map whatever I find in the repository. So Beispiel the ideas of an automatic or code-based extraction mechanism might not correctly map into whatever I'm supposed to do generally. So
Mhm.
it needs to be more of how could this be abstracted? How can I generalize this more than focus too much?
Yeah, exactly.
Me- Yeah.
Yeah, exactly. I think the second use case we have been thinking about was somebody, I think, was doing research on some, I think it was company related data or something. I mean, this is also not a perfect use case,
Yeah.
but I think at least it's more open-ended than the repository, because in repository, more or less, you do just validation,
Right.
um, which is very focused and not so difficult, actually. And I think we have to also think about use cases where people want to achieve something and they put together a few steps, and some of the steps require data collection, processing, validation, and so on. I mean, it's not so different from what you do in your master's thesis.
Yeah.
Because I mean, you do it on the research side, but you also have to collect literature. Think, what do you do? Do you collect, let's say, 50 items, and then you only use 5? How do you process this, and so on, right? I mean,
Right.
it's like making a report or something, or yeah, that's often like this.
Right. For the repository, for example, one thing I was thinking about was that you always have a North Star, which is the document. So the main thing that the repository is doing is the validation is working between the metadata that was extracted, so the representation of the document and the document. But the document is always correct. So the document doesn't change. So you can always refer the document. But in this case, for example, with funders and donors and
Yeah, exactly.
so what is the truth? You might not have some one truth information for that. So it's a little bit more different in that case, for example.
Yeah,
So
exactly.
so the model of the document doesn't change. The document is the truth, but in this case, you don't actually have one true central thing that you could refer to. So that this might
Yeah.
be also different. Yeah.
Yeah. So maybe you take note.
Yes.
Regarding the use case, what are characteristics that discern the different use case types,
Mhm.
so that you can say, okay, what do we have, what can we build on, what is missing, what is difficult, what may change, for example.
Mhm.
Um, or you say, okay, there is no gold standard, let's say, not clear what is a good thing. Maybe you compile a few of these characteristics, and then we use them to define a manageable use case.
Okay, but while I'm thinking and writing, should I focus a lot on the repository and try as a second node afterwards to write about the administration related things that could be used at the table, or should I already think about or
Yeah,
discuss these things already?
yeah. No, I would not go too much into much detail of the repository. If you want to use the repository, really go back 2 steps and look from it from a very wide view. Yeah.
Mhm.
Because from what we are, when we look at the repository, we say, okay, somebody gets a list of documents and references and has to check whether this is valid with the objective material that they can find about it.
Mhm. So it's
Exactly.
just one. It's just
It's
one
also a
example.
report compilation, more or less.
Yeah, yeah. So I should treat
Because
it like, sorry, so I should just treat it like one example among, let's say, five
yeah,
or
yeah,
so
exactly.
that I should show.
Yeah,
Okay, okay,
yeah, exactly.
okay. So maybe
I
you
mean,
can.
another use case could be from your repository software engineering point of view, that you get the job to explore implementing a new function or something, right?
Mhm.
And how do you get the information, and how do you validate the information that you need for this?
Well, can you explain a little bit more? What do you mean?
Now, yeah, suppose, I mean, you are a software engineer, right?
Yeah.
Okay, great. So somebody comes to you and could say, for example, we had a great meeting with the product owner and they want a new function.
Mhm.
Um, and whatever this is, right? And then you need to understand, okay, what do they want, and where's the impact in my software? And if I do this, what are the options?
Ah, so okay. Okay, so
And then you end up again, in our case, you would end up with probably 2 or 3 options how to design that, how to change or embed it into the architecture of the software and the environment.
okay, but in this case, there's no concept of AI or some kind of
No, why not? You could definitely you do it with AI. So this is just a restriction that you have from the current repository
Uh-huh.
context, right?
Yes.
But if you're the architect of the repository and you say, I want to use some agentic workflow, you could, of course.
So okay. So
Yeah.
you're talking more like the Cloud Code or the idea
For
of a
example,
harness around development processes. Okay.
For example, exactly. And
Okay.
the thing is, you don't have to implement this, of course. It's just a thought experiment.
Okay.
So you can go really wild.
Okay. So since you mentioned that I should discuss, let's say at least 5 use cases in this case.
Yeah.
So
Let's
this
say
would
3 to 5, not too much, please. Yes, I don't want you to spend a lot of time of detailing use cases then that you may not
okay.
need later.
Okay. So what would be a third one that we could think of, or should I just focus completely on this? Um, I think you mentioned a repository of or a compilation somebody has to make
Yeah,
regarding funders
yeah,
that they have to analyze a project and who can fund
yeah.
it and
You could talk with Katharina Kaiser,
Mhm.
because I think she has an idea what people do at TU Wien in administration and so on, and maybe she has some ideas about use cases, or maybe she can relate you to 1 or 2 persons to talk to so they can give you an insight what they do.
Okay. So in that case, I would focus on these three only. Then I will just restrict it to the three.
It's important that you get an idea about the general structure and what you need for these the use cases. The number is not so important. It's more important that you understand, okay, what capabilities does your approach need to be able to handle.
Mhm. Okay.
Yeah, because if you describe 12 use cases and they're all the same and don't give you any new insight into the capabilities, it's not useful, yeah. And if you
Okay.
have only 2 use cases and they give you all the capabilities, it's great.
Okay.
So the number is not important for me. The essence is important.
Okay. So what are the different problems that a
Exactly.
solution
Yeah.
might find, and how could we fix this? And do they represent more or less what the
Yeah.
problem
Yes,
space could be?
I suggest we go through what we wanted to discuss today, and then in the end you can see, do you have it or do you need more information? Okay.
Okay.
Good. So the strategic goal of your thesis is about how to consider agentic workflow solutions, yeah, and for improving the performance of a business process at your Win.
Mhm.
So it should become somehow better. Should be more effective, more efficient, more resilient to change or whatnot, right?
Yeah.
So this is something you have to define. And for example, one thing is that oftentimes it is that an expert starts a business process
Mhm.
and they can do it after some time very well, and then this person leaves TOV and somebody new does it, and there's no documentation, and suddenly the performance of the process is really bad.
Mhm. Okay.
So
So how?
here the improvement of the performance would be better documentation of the how to do it, right?
Yeah.
So, and the change would be that somebody else should do it, not the inventor, but the second person.
Yes. Yes. Correct.
Okay.
So
And then you have to consider regarding this use case and performances where and why to apply with an agentic workflow. Yeah. So
mhm.
what is the argument to use or not use an agentic workflow?
Okay. Um, So codify the documentation in what the so-called skill that they talk about these days in a skill format, so that an agent is able to quickly, and any agent, this is an agnostic skill, that it's able to pick up this. So like for a human who will be a
Yeah,
documentation, I guess, then it could reuse the same prompts and the same steps what a task should be. And are you thinking that in this direction?
I think that's an excellent, interesting question because usually a person prototypes the process. And maybe here it's a good point below you can see here the figure 1.
Mm-hmm. Mm-hmm.
Yeah. And in the figure 1 you have a process. In this case, the process is an assembly process, but it's not important. It could be any kind of business process.
Mm-hmm.
For example, it would be compiling a report and doing research about this and so on, right?
Yeah, yeah.
And this is the base process, and the output is actually what people are after. So you want correct output, you want high value output, and you want this process to work also if there is some, so there is always uncertainty in the environment, okay?
Yeah.
And the uncertainty could be, for example, that the operator, the person doing it is a different person.
Right.
Yeah, and you want to have a process that provides predictable, at least minimal quality output.
Mm-hmm.
And then you always have here, you see an example on the next layer here, the human, and the human is supported by some kind of machine. So you have a human machine team.
Mm-hmm.
Yeah, so in the old days, yeah, let's say 50 years ago or so, or before computers,
Yeah.
you just had the operator and a lot of paper.
Mm-hmm.
Yeah, and now instead of the paper, people have the machines and the databases and so on.
Right.
So today, I think you can safely assume a layer here of one or more human machine teams.
Mm-hmm. Mm-hmm.
And this is
Okay.
the first that we have to understand, of course, yeah?
Okay. So, right. But it would be, yeah, it's a human that checks the machine's output in this case, or is it a human that is
Now
being
think about
checked?
it. Really think about it. Let's go back to the report compilation process,
Yeah.
okay?
Yeah.
Suppose here you get as input the order to, let's say, for 30 companies to make a report for the vice rector of research, to make a company report when they talk with somebody of the company that they have the necessary facts for briefing.
All right.
Okay, then somebody thinks, what do I need for this? They think about the output. They say, aha, for each company, I need some base data and I need some interesting research related, maybe what have they done with TU Wien in the past or so, okay?
Yeah.
And from these output requirements, they go back and say, what steps do I have to do in this assembly or this research process, reporting process?
Mm-hmm.
And then they say, okay, I have to open up a new report item. Then I have to find out something about the company on the internet. Yeah. Then I have to find out something in TU databases about past research projects.
Mm-hmm.
And each of these process steps has sub processes. For example, where do I find the information about TU related things and so on. So they break it down and they have sub process, and then you do the same thing all over again, right?
Yeah.
Yeah. So they have a kind of a plan, and the plan involves some assumptions of accessing data and knowledge, right?
Yeah.
And then they find out that they don't know some of these things, so they could call other persons.
Mm-hmm.
Yeah? They could ask somebody.
Mm-hmm.
Yeah. Think like in the old days, you would ask somebody. Today, maybe you would ask a database, yeah.
Yeah.
Or you look up some documentation on the web, in the
Mm-hmm.
TU internal web,
Mm-hmm.
or today also you could use some AI support, right?
Yeah.
So I think really if you go from the 1950s solution, just paper, yeah, and
Yeah.
people, then you go to the 1970 approach, editors,
Yeah.
and documents, and then you
Yeah.
go to the 2000s approach, databases, yeah, and then you go to the 2010 approach, internet documents,
Right.
and then you go to 2020 AI.
Mm-hmm.
But if you go to this timeline, always you have the operator and you have some kind of machine. It's just a tool like an editor,
Mm-hmm.
or it's already something collected with doing some support, yeah, like database or so.
Right.
and it's increasingly complex and increasingly versatile, I would say. So there is a shifting. I gave you this knowledge-intensive process paper from DiCiccio. Yeah, it's in the references here.
Mhm.
You have it here, DiCiccio. Yeah,
Yes. Okay.
knowledge-intensive process. And the topic of this is that you have a very structured automated process to less structured processes. Yeah.
Mhm.
And this is exactly the same, this historic shift from most has the human has to do most, yeah, and then more and more unstructured stuff can be done by the computer.
Okay. So this operator doesn't necessarily have to be a human, though, right?
Yeah, no, yes, we say the operator is a human, yeah.
Mhm.
Let's say we have a human machine team here.
Okay.
And in each human machine team, you can have either a huge emphasis on the human does almost everything, and the computer is just a tool,
Mhm.
or you
Okay.
can shift more and more responsibility to the computer,
Mhm.
the machine. And then in the end, you have a stupid operator who just waves everything through what the AI says.
Okay. So in order to have accountability, to blame the human, or that kind of.
Yeah, no, yeah.
Yeah.
In the end, the human is responsible.
Yeah. We need to have
But
somebody.
the problem is that the workload, these processes has risen dramatically. Yeah, if you go back to the 1950s, one person would have to compile the report, let's say 4 weeks.
Okay.
Yeah, now I want it in an afternoon.
Yeah. Right.
That's a difference.
Yeah.
And the
And
human
do.
could say, it's very difficult to access the data, and everything takes time, and I have to send a letter via and so on. Yeah.
Yeah.
So this
And
can take very long. So the one thing that you have to also take into account is the time, because if the time window is very tight then the human cannot check it anymore. There's an overload on the human
Mhm.
then.
Yeah, this is the other thing you reminded me. I only thought of complacency when I was thinking about feedback. Um, that if, like rubber stamping, if they see too many correct validations, so that if the machine is making too many correct
Yeah.
judgments, then the complacency goes up. And I thought of adding some kind of decay function as the correct answers increase, that the human gets more and more complacent. But I only
That is
saw it from.
one point.
Yeah.
I think that today people are just cognitively overloaded.
Yeah, that's another thing that's yeah, additional. Yeah,
No,
yeah.
but this is historically already in safety, yeah, machine safety. Think about an operator, an airline pilot with hundreds of indicators to check and so on.
Right.
Yeah, and there were a lot of problems with airplanes and so on because the user interface was not good.
Right.
And this
And
improved over time. But in many other situations, you don't have the strict safety concerns of airlines and so on.
hmm
And therefore, you can have bad user interfaces and or also acceleration. Yeah.
hmm
So somebody who has been doing this for 10 years and knows exactly how to do it and what can go wrong and so on, they are very efficient and they can really focus on the few data elements that are important. But the new person is totally overwhelmed.
Yeah. Indeed.
Okay.
And yeah.
So just to summarize, so we have the basic process. This is what you want to improve. So what you want to improve the performance of the green stuff.
Okay.
Most importantly, the output,
hmm
but also the process. Of course, the quality of the process is good.
Okay. And the quality of the process, not necessarily speed. We're talking mainly about quality, even if
Now,
speed.
quality is all non-functional aspects.
hmm hmm
Also function is that you can make the report, let's say, and all non-functional quality is, for example, correctness, efficiency, of course, duration, and so on.
Okay.
It's a lot. So if you look in software quality, it's not just correctness. It's everything else. And the problem with the process is that the environment is uncertain, changing, and also that these human machine teams are changing. So in the best of all worlds, they learn and they become better.
Yeah.
And in a typical world, after getting better, they get worse because there's a new operator or there's a system update with with some bugs or so.
Okay. So this is the model drift we mentioned before. So that a new person coming in is also an instance of a model drift, I guess, because
I would say it's a change. Just think about it as change and uncertainty.
okay.
So you have to make a design first of the process in the understanding that there is uncertainty. And the second is you have to characterize who is working with the process. Is it one human machine team or is it more complex?
Okay. So think about different examples of how the process, so the human machine team could be organized. So it could be in the worst case like this, in an optimal, in the best case like this, and so on. So I should think like this then. Okay.
Yeah. Not too complicated, right? So that you say in the minimum, I have a new operator with just an editor and access to the internet.
Okay.
What do they do? Yeah, or I have an operator with already a workflow focused on this process.
Okay.
What do
And
they
what
do?
what happens when the operator changes? What happens when we have no
The
manual?
agentic workflow.
Yeah.
Because the agentic workflow would be here in the machine side, right?
Yes, but I thought the agent could also be the operator, to be honest.
Yeah, but in the end, when you say the agent could be the operator, then you are just shifting human functions to the machine.
Yeah. Sorry. Yes, that's correct. Yeah.
That's
As soon.
okay. That's okay, but the operator, never the machine is the operator. You're just shifting, yeah. You're changing the balance between the operator and the machine. I mean, if you look at autonomous driving,
Yeah.
there are different levels. I think there are 5 levels of autonomous driving.
Yeah.
And I think that's very similar to what you're saying here. Yeah. So the machine should take over new capabilities, okay, and how can you, in a trustworthy way, shift these capabilities and make sure that the oversight about the process is never a problem.
Yeah. This really maps correctly for me in my mind. The
Yeah, and
driving.
I think that autonomous driving is also important because it's not shown here. But what you also have here regarding the machine, you have a safety layer. And you have a function layer in these production machines, for example, but also for autonomous driving. Yeah. Because in the function layer, the operator and the functional part of the machine issues certain commands. I think this is very similar to the Leveson view with the controllers. Okay. And the thing is that the functional commands can be wrong and can exceed the safety of the system. Yeah, I give you an example. Let's say somebody is driving in a way that the machine heats up.
Yeah.
Then a safety mechanism has to take care of not overheating.
Correct, because the functional part doesn't care about, or it
Doesn't know.
Yeah, doesn't know. Sorry, it's better that it doesn't know. Yeah.
So you have 2 layers here. You have the safety layer and the functional layer.
Okay.
This you have to know. And this is because this is also true for all these business processes. Because if you think that the machine takes over certain functions, you have to define the underlying safety.
Yes, yes. Okay, okay.
For
So,
example, if you say if a safety concern is that that internal information is not shared to the outside, yeah, then
yeah,
the AI will of course try to do this.
yeah.
How do you make it still safe?
Yeah, so guardrails, removing rights,
Exactly,
yeah, and stuff
exactly.
like that.
Yeah. So think here about safety and about function here, yeah. And then in the best of all worlds, we would be done. We would have the human machine teams with safety and with function. We have done the architecture and we are fine. But in reality, these teams and processes don't work perfectly, in particular in uncertainty and change. And therefore, what we do is an analysis of the process and its socio-technical environment. Socio-technical is the human machine team. And we make this analysis. And if we make the analysis with Brocando Business Intelligence and with the Leveson, the STAMP STPA control system analysis, we find out that there are some situations that are critical and that are not handled well by the current system.
Correct.
And what you can then do is that you say, okay, how can we improve the current system? And then you make a list of improvement requirements, let's say. And then you have to look at the solution architecture as is and say, okay, which elements of the solution architecture can I change to accommodate these improvement requirements? And sometimes you will find out that it's not possible, maybe because you're using a legacy system that you cannot change.
Yes, yes.
Yeah, and in this case, you make a new system here. Here it's called an assistance system for the production, yeah. But it could be, this is what we have, this operator guidance and the supervisor system. That you say, what do they not do well, where do they need guidance, and then you make you introduce a new system that tries to address these improvement requirements by interacting with the operator and the systems, the human machine team.
So this is the control layer, I guess. So
It's this is the it's a bit difficult because the question is how much can you really control? Yeah. So it's more like a, the supervisor or guidance for the operator. So do you have here the quality manager or supervisor sitting and they think, okay, this system is not working properly in some respects. How can I find out what does it do? And how can I, at the right point in time in a scenario, provide adaptation instructions or escalate?
Okay.
And this is in the end, this is the scenarios that we make in the Brocando Business Intelligence. In the end, you have these adaptation scenarios. I sent you this paper. I sent you this paper here. CMTFL.
Did you send it to me now, or
It's a link. I sent you the meeting agenda, and in this agenda is the link.
Okay, I will open it there in my place.
Yeah, that's important.
Okay. Yeah, I'm looking at it also.
Okay, great.
So, is it okay, or would it be better to do the as is representation with this figure that we just looked at, and also the to be also with the same figure, or how would you use it? Because I was assuming this figure is perfect. This one is for the to be the design, or maybe I could also use it for the as is.
it's you have to transcend this, yes? So you have here the different layers. You have the layer of the process.
Mhm.
This you can make, for example, with an IDF0 or so.
Mhm. Mhm.
And with the IDF0, you would have the human machine team just as a resource.
Mhm. Mhm.
Yeah. And then you would have the assistance system also maybe as a resource, okay? Then in the architecture, you can have these layers, the process, you have the human machine teams, and you have whatever other systems are important for you.
Mhm.
But this is it's just an architecture structure, how you view it, yeah. And we came up with this figure to illustrate the Leveson control cycles here. Because you
Okay.
have here this control cycle from the production system, you see it here.
Yeah. Yeah.
And you have not shown, but you have also the control cycle from the operator.
Mhm. Mhm.
Then you have the lateral coordination between the operator and the machine.
Mhm.
Possibly you have several operators and machines, so that you have lateral coordination between all of them.
Mhm. Mhm.
And then you have to consider how do you provide the guidance. So you have here another control system. Yeah, you have in the background another control system.
Mhm. Mhm.
But in the sense of the Leveson, it's really questionable whether this is a hierarchical control
Mhm. Mhm.
or whether it's also lateral control with this.
Mhm. Mhm. Yeah. 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 Yeah.
Because it's not really said, okay, how authoritative is this? This is usually a runtime system, yeah.
Right. 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 Yes.
It may also be wrong, yeah, because it may be out of sync. Because what you're arguing in this paper is in principle that according to the Leveson theory, accidents or hazards occur because the model of the system, the operator, or different operators and systems, and the real process are not aligned.
Right. Right.
And then you introduce as a remedy a new system with new complexity and new failure options.
Mhm. Mhm.
So you actually make the problem more complex.
Right. Right.
Yeah. So I think a key question also for your work is if you introduce a agentic workflow or whatever you introduce, you introduce new complexity.
Mhm.
Under which circumstances is this really an improvement?
Right. 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 True. And yeah, maybe if I could say this, I've been reading quite a lot of unpleasant things these days. I mean, I'm extremely enthusiastic about this AI stuff, but I mean, the woes and the worries are coming from the market side, of course, but it's
Mhm.
based on the fact that this hallucination and every percentage of improvement extractions that they make is another layer of um, prompts and another layer of don't do these things and do these things, and it seems
Yeah,
like it's not really improving that much that businesses can really lift off with it, so that they could just
yeah.
fire all their software engineers, for example. But it's
I
not.
think I think Solomon, this would be actually a very good contribution, meta contribution of your work.
Yes.
That you say, look, we have an as-is system. Let's say this would be the lower part with
Yeah.
certain elements and certain strengths and certain limitations.
Yeah.
And then we introduce a new element, yeah, and then we say the element should address certain limitations, yeah, but not remove the strengths, which is
Right. Right.
also interesting, yeah. And then you will say, okay, now I introduce a to be system with a new element, and what is the impact that I expect? Because in
Mhm.
the best of all worlds, you would address some limitations of the as-is system.
Right. And also
And
introduce some new problems, I guess.
exactly. And this exactly that you should discuss.
Mhm. Well, one more thing, if I could please, because this intrinsic problem of this hallucination, like the central problem is that. But on the other hand, a human is also a hallucinator. If you
Yeah, of course.
if you think of it, we are
I
also a
I
next token
I forgot
predictor.
Also I would not go for hallucination actually, because hallucination is for me just uncertainty, and you
Yes.
have a lot of uncertainty here, and you have to deal with the uncertainty anyway. So hallucination is just one aspect of it.
Right. I mean, if we could
I think
just, yeah.
I think it's much more dangerous to think if you look at this as an adversary scenario,
Mhm, mhm.
that you don't have an hallucination, but that you have a conflict of interest
Between the human and the machine, or what do you mean?
between stakeholders.
Also, okay, okay, indeed, indeed.
Now you had this already in the repositum case, yeah, that you have the two validator stakeholders with different interests,
Right, right,
and they made a lot of problems because of the conflicts of interest. So
right.
this is not uncertainty, it's much worse.
Yeah, yeah, yeah. Indeed, indeed. But
So so what I would say is that we make a strong framework for analysis.
mhm,
Then you get a strong analysis where you say what could go wrong and what are the scenarios for going wrong. Then you think about how do you want to improve it as a
okay,
solution architect. Yeah.
okay.
And then you argue, okay, how could I improve this? What would be the easiest to do?
Mhm, mhm,
And this could be, for example, improving the operator, training the operator, ensuring conflicts of interest are resolved somehow, maybe.
mhm,
Or you say, I improve the tools or the data on this side here.
mhm.
Or you say, I cannot improve this, I introduce something new. So all of this is okay, but we want a strong analysis framework that allows you to assess and compare the different solutions options.
Okay, okay. Because as it is currently, you might have the problem of a validator having different interests, which the agent might not have. But on the other hand, the agent might bring along the stochastic
Yeah,
nature of accuracy. But one thing I'm not really sure about is that the human is also a stochastically accurate entity, right? So why
yeah,
would
yeah.
the agent be singled out as that in this case?
It is
Um,
not. It is not. It is not.
okay.
It's just you have uncertainty coming from the operator, from the environment, from the machines, from the interactions between them, and so on. So nobody is singled out. It's just you have just to understand what can you expect from them.
But for your machine, for this example where you made this example with the pressing, the haircut issue, the haircut
Yeah,
example,
exactly.
you
Yeah.
never had to think about, oh, the margin is stochastically. I mean, there probably some error margin, but it's not such a big deal at that in this world, right? Like where you say the Martian might press it really strangely. The only thing you care about is it pressed hard or not. Maybe it's not such a variation of possibilities that you
Now
expect out.
we are talking here about the output, yeah.
Right.
And the output in the pressing case would be that you have possibly several products that are not good that you sell to your customers, and they put it into larger machines and larger processes, and they
Yeah.
will fail prematurely.
Hmm.
So the argument is the business performance that you have guarantee and lawsuits later with your customers.
Yeah.
And this you have to evaluate. If you say this is not a big deal, then you think about something else. But if you think this is a big deal, then you have to go back and improve your process and everything that we considered here.
Okay. 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 Right. So yes, I think I got the main thing here. This is the that we have also failure points, and we
Yeah,
can categorize those failure points, and we can say as
exactly.
is these are the failure points, and in the to be these are the new failure points, and we remove these failure points or something to
Exactly,
that.
exactly.
Yeah.
I think possibly you will not say remove, but you say you have a stronger capability to mitigate them, or at least that you reduce the probability of them to
Okay.
occur.
Okay. Okay. Okay.
Okay, so this is what we should do here. then the driver of the analysis is the sponsor pain point.
Mhm.
So here we say high cost from guarantee from bad products, for example.
Yeah.
And the sponsor pain point usually occurs because of a change.
From the
It could be
expected.
external.
Yeah.
It could be an external change that you have new inputs, new processes, or the environment changed. You get less money, or you have to do things faster. Or you can have an internal problem that, for example, you don't have the operator anymore.
Mhm, mhm, mhm.
And this causes a sponsor pain point, and this you have to clarify because this is the anchor for everything.
Mhm, mhm. So you
And
mean
this requires the adaptation of the as-is process.
mhm, mhm. Based on
Because
an interview, for example, you mean? So
this
so
is
I.
it's a this is it could be a discussion with a sponsor, but in our case it's just the specification of the improvement that you shall do.
So okay.
If you compare it, for example, to Valentin's thing, the improvement was takes too long, is too expensive, too much error. We want this better.
Mhm, mhm. Okay.
So the change could also be that a new sponsor takes over an SE's process and say this is in a bad shape.
Mhm,
It has to change.
mhm. Okay.
And the question is adaptation of the SE's process and solution architecture. So the SE's process is the green thing here,
Mhm,
and the solution architecture is everything around it.
mhm. Okay.
And you have to understand the around, the environment here around the process in order to say where can I change something.
Okay.
So you have to explore the solution architecture options. Yeah, what can you change? What should you change? Should you change something with the operator, with the human machine team, and so on? Or should you make a new guidance system? And for you, at some point, there should be agentic workflow involved.
Yeah.
For example, if you say agentic workflow, you put it here as a new kind of machine.
Yeah.
Okay, how would this interact with everything else?
Okay.
Yeah, or you look into this process and say there were many steps of the operator where they didn't have any support, and now with AI functions you can improve this support. How do you do this?
All along, though, when I'm doing this, I'm doing it for one particular example, right? And then doing it for another example. And maybe after doing 3 examples, I could make one that represents all 3 or something like this. Is it the
Something
direction?
like this. That's the idea of the viewpoint. So the viewpoint would the architecture viewpoint describes an architecture for a scope of applications.
Okay.
And of course, what you need in the beginning, you need a concrete example in a family of applications. But in the end, you shall write about the family of applications with the example as an example.
Okay.
Because the contribution from your work is that somebody else who has a similar problem can apply it. They are not interested in your specific use case
Right.
because they don't have it, right?
Right.
They want to solve their use case.
Right. Correct.
So this should be a blueprint for people at TUWIN to consider when and how to use agentic workflows.
Okay.
So the general approach would be from my understanding. The first is you analyze the sponsor pain point and the as-is process in the socio-technical environment. That would be the lower part here. Okay?
Okay.
Then you find out certain problems and issues that should be improved, make a list of things that should be improved. Then you ideate creative solution options. And here agentic workflows must be one variant. And then you design to-be process and solution architectures, at least one including agentic workflows. And then you assess and compare these, the to-be variants and the as-is baseline. So
Okay.
at this point, you need to have at least three
Right.
variants. You have the as is, you have the to be without the agentic,
Yeah.
and the to be with agentic.
Mm-hmm. Okay.
And this would be this described well with examples would be in principle the core of the thesis.
Okay.
And of course, you need to implement and validate one of these variants with agentic workflow to show that it works really.
Yeah. So some Monte Carlo stuff, the adding some other um,
Again, you will see you will propose at the win where would agentic workflows be applicable,
mhm.
and then you will select some of these and say, look, this is how this could work, and then somebody else could do other options.
So okay, so I would just show one of the examples how they
Yeah, of course. Come on, you cannot solve everything.
probably the repository would be a good example because a lot of the groundwork has already been done by Valentin, so I could improve on his Python scripts
Yeah,
and
but
his findings.
but you need to go back. I don't copy of Valentin's thesis.
Mhm.
If for us, the repository would be just a validation workflow. We don't care about the details actually. We don't care about the conflicts between the stakeholders and so on, right?
Yeah. Okay. I think I didn't understand this properly last time because I went too deep into
Yeah, that was too
understanding.
deep. But that's not our interest because if you go somewhere else, probably you will not have the insight in these stakeholder conflicts.
Mm-hmm.
But you still should be able to make an architecture proposal.
Yeah. Okay.
I think you should really start from the process, describe what are the process steps, describe what do you need for this, yes, and then say, okay, where could be problems and what do you do about it. So you don't need to know a lot actually about what Valentin did. For example, you are totally not interested how long now they keep the record somewhere. Who cares, yeah? Your focus is to improve this process.
Okay.
And if the sponsor say it takes too long, then you think about how to make it faster.
But one question here isn't the cost benefit. So if the improvement doesn't gain you as much improvements as the cost of producing the solution, then shouldn't you really then be concerned about how much improvement you're making? Because
Yeah,
you
of course.
said,
Yeah,
yeah.
I'm with you. But this is really a question on justifying what is the benefit and so on the business performance side. And I can argue that you can say that you can argue about the business performance side without making it a very detailed research here.
Well, the reason I bring this up is because you said it's not that important that you know how many minutes, for example, is being
Yeah, no,
shaved
yeah,
off.
it's true. Yeah.
Because
Yeah,
that
because in the end you have a sponsor and the sponsor has to agree to take the cost of or not, right?
yeah.
It's their call.
Also, okay. So if they make that demand, then I can assume that there's already a well-established argument for making the solution, and that I don't have to
Yeah,
justify it myself.
exactly. In particular, what is the cost or what is the benefit of reducing the minutes? Yeah,
Hmm
that's very questionable.
Indeed. When you
Because if
actually,
somebody says we have to produce a report, let's say in January, yeah,
yeah.
I don't care if the records lie in the summer for 3 months. I don't care.
Hmm
Yeah, so that's why I would not go into this detail. You are opening too many
Okay.
new aspects that don't help you.
Okay.
So, and then we represent the result in an ISO 42010 viewpoint
hmm
so that somebody in the future can pick it up.
Okay. So this is I think I opened it very briefly this morning when I woke up. But it's it's some kind of structure
It's a
template thing, right?
structure. It's a
Yeah.
structure for reporting how to model something.
Okay. Okay. Yes, I'm looking
It's,
at it.
it's really very well aligned to what you have been doing if you have been following this, what we discussed before.
Mhm. Okay. Okay. Um, right. And
So, and from
regarding.
this viewpoint, what you say is you have stakeholder concerns.
Mhm.
For example, your concern could be when is it advisable to add agentic workflow and what architecture concerns do we have to consider here? Yeah.
Mhm.
And then you need to describe what do you need to model for this. So you need to understand and also describe what models are required.
Mhm. Mhm.
And
Mhm.
in order to make this easy for you, I suggest that you just follow the Vocando Business Intelligence approach, the tutorial that you have been using for the Popal,
Yeah.
and that you extend it with the Stamp SDPR variants to improve the solution architecture by thinking about the control systems here.
Mhm.
What can
Mhm.
go wrong from the Leverson side?
Okay. Okay. And one
Because
question.
then you have a set
Yeah.
of models to start from, and then you can think, okay, what is really helping you and should go into the viewpoint in the end, and what could be simplified.
Mhm. Okay. Okay.
Please.
This regarding adhering strictly to the OAS. That's what it has, I think, right? The this figure that you have opened here. Should I
Yeah.
adhere exactly with the diagram specification? That I mean, if you saw mine, it looked a little bit different. I tried to be aligned to this
Mhm.
the logic of it, but I didn't adhere directly to the figure specification, like sensors is in a box, so for example, like this type of things. Should I
But
adhere?
you have to think about this. You have to think about it. What you need in the end, you need a clean modeling approach, which is based on existing models. Yeah. You should only invent something new if it's really, really necessary, and we will discuss this.
Okay, 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 okay.
But normally you should follow existing. I mean, there has been modeling for 30 years, right? So
Yeah,
why should we do something different if it's already solved?
yeah, yeah. Okay, okay.
So that's why I say. So what you see here is the control system according to Leveson, yeah. And I'm not totally happy. I mean, it's a nice illustration, but I'm not totally happy with this. You have to think, what do you need? And what is very important for the Vocando business intelligence, the rationale is that you work with domain experts who are not experts in modeling.
Mm-hmm, mm-hmm.
And that means we want models that non-experts can understand.
Right, right, right,
Because the answer could always be, why don't you use SysML? Or why don't you use BPMN 2.0? Or why don't you use UML? Naja,
right.
because non-experts in modeling just don't understand this. And as soon as you move into this modeling space, then you lose contact with the domain experts.
Right, right, right.
And
Okay.
I think also in this ISO 42010 viewpoint description, you need to say, okay, which models do domain experts have to understand, because we need to discuss this with them.
Mm-hmm, mm-hmm.
And my understanding would be it would be the Vocando Business Intelligence, also it would be these things here,
Yeah,
this simple
yeah.
architecture and the simple impact path and the scenarios.
Mm-hmm.
That's why I sent you this paper. Uh, and then maybe you need advanced for the analyst, yeah, you need advanced models, and then you can use any kind of models that also domain experts don't understand.
Ah, okay, 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 okay.
But you need at least a layer of models that domain experts can understand.
I see. Okay, okay, okay. So I could lay out the bigger picture, let's say, in this easy to understand Procando, and then go more into detail, explaining, maybe use BPMN or UML or something like this for.
Yeah, because Solomon, think about a product owner and a software engineer.
Yeah.
The product owner has to work with the domain experts. They need to use the models that also the domain experts can understand.
Right.
Then this goes to the solution architect, and the solution architect then goes into the software engineering professional models, let's say. But the magic here that we do is if you think about the software architecture is only in here.
Right.
It doesn't think a lot about the rest.
Yeah.
And what our contribution is that we think about the socio-technical system of the process and the human machine teams and everything, yeah. And from the solution architecture that we derive from here, the requirements for software engineering architecture come.
I see.
Because from this system, you will have several software systems that have to work together. And you have to explain for the overall solution architecture how do you distribute the responsibility for certain things. And once you have said what system is responsible under what conditions, then you have requirements for software.
Right. Yeah, correct. Yeah.
So you are working here before software requirements. You are providing the rationale for software requirements for different systems.
I see. I get it now.
Because the software people never think about these things.
Yes. It's a tunnel vision. Always care about the solution.
Yeah, the problem is they make a nice piece of software that is totally useless.
Yeah.
Because they don't understand the environment changes, and the super software that they made over weeks and months with a lot of hard blood and so on is useless.
Yeah.
It's a pity.
Yeah. This is too many examples like this, unfortunately. Yeah.
Exactly. And the core of all this is these scenarios.
Yes.
Because these scenarios are the boundary object between the domain experts. They can understand this. And we use this impact paths and so on to validate them. So it's not just any scenarios, but it's really validated scenarios. And these are the input to the software solution people to see, what do we have to focus on?
Correct. Yeah. So the main what is this the thunder sign that shows I forgot the name that you used it, but the main pain point, I think, also where the drift in model, for example, would be the consequence for the drift in outcome. And
exactly. Because very few people understand how certain local changes are together impacting system level issues.
Right.
And this is what this viewpoint has to support. Because once you understand how the big picture outcomes are influenced, then you can really think effectively about the solution architecture.
Right. From the Procando, which of the 6 are most relevant? Is there any that I can drop and only focus on, or should I always keep them together?
What do you mean?
From IDF 0 until the mirror, the digital.
But this is what you need to find out actually, Solomon, because if you argue you need it, then you have to explain why do you need it, yeah? And if you say you don't need it, then you have to argue why don't you need it.
I see. Okay. Wow, it's very open.
What you need to find out.
Okay. Okay, okay. Because I
I also,
remember.
but I didn't. But I mean, we worked with this, and we followed in principle the process to find out with the sponsor what's the pain point, what do they want to improve, and
Mhm,
then to explore this and get the knowledge of the stakeholders together and so on. So that's how we came to them. So
mhm.
I think they are, of course, they are important. If you have an idea how to how or where to remove them, okay, great.
I mean, in that way, it's not to remove them, but more in the sense where which one is the most important of are they all relevant? But like you said, I would discover this as I go. Do I really need to use this to show?
I give you several ideas about this, yeah. Also, if you ask me from what you are looking at now, I think that the scenarios are the most important boundary object because they come from software engineering, from test automation.
Mhm, mhm,
So they are a native translation means to software engineering.
mhm, mhm,
And we have been validating them in the Vocando context, so they are not just understandable to software engineers, but we make also sure that they capture the relevant information about the social technical system here.
mhm, mhm,
Also here you have, for example, a stakeholder, you have the stakeholder win conditions.
mhm.
Yeah, you have a problem also here. Then you have here the background. You see on a certain critical path in the process what happened before and what do I have to get there.
Mhm, mhm,
And then you have here an illustration of what can go critically wrong.
mhm,
So here you have a pain point that you say here the share of the bad metal parts is high or whatever is important for your process.
mhm, mhm,
You have also an idea why this went wrong.
mhm. Yeah, yeah.
Okay. And then you have here an adaptation scenario which starts very similar, but which has then the adaptation instructions.
Right.
And you can use these adaptation instructions to instruct the human, or you can use it to instruct the human machine team.
Okay, okay. So the adaptation instruction is also part of this image then.
Pardon
Okay.
me?
I thought I always assume that the this image only shows you the 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 the, the way where it fails you, and it doesn't necessarily explain what adaptations you should introduce. I didn't realize that you could also mention
Here you have both.
these
Here you
things.
have both.
Yeah.
But of course, in different. So if you look at the life cycle of a solution,
Yeah.
then the problem would be more at the beginning during the analysis and design to say what do we have to get better.
Mhm, mhm.
And the lower part is an example for later a solution option, which also could go to runtime.
Okay. Okay. Okay.
I mean, you could use for monitoring both of them
Mhm,
because you could monitor at the runtime which conditions are true. You measure the data. That's why you need the data space.
yeah.
And then you can monitor, okay, how often did we run into this problem?
Yeah.
And how often did this occur?
Mhm, mhm.
And one of the improvements is that we not only describe this, because in a program or in a process, people could follow the process, but
Mhm.
they don't document the data.
Yeah, right. But if you have this side note next to the send undesired, do you
Yeah.
really need still the desired version because you're actually saying a lot with this the side notes here on the undesired part?
This it's true. It's also a question of the life cycle. Yeah, people usually come from the desired
Mm,
because you need to discuss with the sponsor and the stakeholders the desire, so you get a common starting point.
okay, okay. So
And you understand what are they thinking about, what do they assume will go well,
yeah, yeah.
and then you make it more difficult by introducing undesired.
Okay, okay. But I understand now. It's actually because you want to. This is really made for the plain English version, so to say. So the person who doesn't necessarily um, understand the system. You want to communicate with a non-technical person. So having the desired version also additionally would just make it concrete for the person. So I can see it that way, yeah. Because for me, like when I see the undesired version,
If you say desire, do you mean the background here, or do you mean the green version of
the
the
green,
diagram?
the green version of the scene. Yeah.
It's usually just in the illustration like this. In the reality, what you start is a small green,
Yeah.
and then you get a large pink.
Yeah. Yeah. Yeah.
And
It's
you have to think about life cycle also. This is maybe a good point. You have this here. Yeah, I put this here also. Consider the life cycle of the solution development and evolution. And you have here the design, also you have design time.
right.
You have the analysis. And you have this solution design.
And then you have the run.
And then you have the runtime.
Yeah.
And then you have the monitoring.
Logging and
Documentation, yeah.
Yeah. Yeah.
Logging, yeah. And then you have the adaptation and escalation.
Which would be the feedback loop back to the design, I guess, right?
Yeah, this would be that's the problem actually. Good that you say it. So escalation means, for example, escalation to a supervisor.
Yeah.
And the supervisor makes something, but the question, if this is not documented, there is no feedback.
Indeed, yeah. This is what I missed also. So if there was no example, if there's a disagreement or a runtime produces some error, eventually some supervisor needs to come up with the resources and the idea of a solution, I guess, right? So
Okay.
he's the ultimate adjudicator.
And it's like with the program, if you let's say you would run the scenario in a program, it would make the checks.
Yeah.
And it would select the correct path based on the outcome of the checks.
Mm-hmm.
But in general, a program would not document the state of the data.
Right.
So you can later measure the outcome, the then part, but you do not know the given part.
Unless,
and
of course,
this is the problem why people cannot learn, and also systems cannot learn from this.
Yeah.
Because if you don't know the given, then how do you know? I mean, you can say 90% is good and 10% is bad, but I don't know why.
Yeah. So it's another layer of thesis, I guess, that finds out based on the exposition of the system itself, or if we can call it logging, on runtime, what the system logs itself, or it shows why it made a decision, a very detailed, explicit way, and then another validator or some sort would say then, oh, this is a good argument that it made. Of course, you need to trust the argument that it really did what it says, I guess, because this is something that you can't really verify easily, because if it tells you, I took this decision over the other one, you have to trust that it did it. But if you trust that, if you passed that layer already, then you would say, you could argue that the decision made was correct or incorrect afterwards, at least. Yeah.
Exactly. This would be important. Yeah, that you can, because if you assume that mistakes are made,
yeah,
the question is, what data do you need to record to follow this? And therefore, these scenarios are so important because they are linked to the impact paths across the different domains. And you can see here that you need different knowledge from different domains to understand how this is connected. And from this, you distill what to document, and from this, what you document, you can follow later this path.
Okay.
And what today happens is that on the machine level here, on this software level, lots and lots of data is recorded that is totally not connected to the rest.
Mm-hmm. Mm-hmm. Yeah.
Yeah, and then you get lots of crappy, unnecessary data, which does not explain what you actually want to know.
Right.
So it's
So
not just that the good stuff is not logged, it's even worse that a lot of noise is logged.
that's the word. Yeah, the noises. Yeah. Yeah. Actually, maybe it's even worse if you have too much noise that you could have found the truth easier, but because of the bombardment of so much unnecessary
Yeah,
or unrefined information or data, you get lost. Whether you are a human or a machine, I guess.
exactly. And this is what we say with the architecture impact gap.
Mhm.
And this is what you should actually address with this ISO 42010 viewpoint, that you
Mhm.
say how to bridge the architecture impact gap, because the architecture documentation may be disconnected
Mhm.
from impact.
Mhm. Mhm.
And this is usually missing, this part. And this is why I think this is a very important boundary object, the scenarios,
Mhm.
because this is what everybody understands, the domain experts and also the software team, the tech team. And
I-
this is important because this is the multi-domain integration of impact.
Right.
This is actually the core of the analysis and improvement.
Right.
It is important that it is validated with the architecture, because if it's not validated with the architecture, people can invent anything here.
Mhm. Yeah.
And we came to this from making the architecture sketch and then doing the backtracking from the undesired outcome to the process, to the people, to the input, to the systems, and so on.
Mhm. Okay.
And usually, if you have just a process model, then you
Yeah.
get a very shallow idea about the systems.
Mhm.
Also if
Yeah.
you think about the BPMN or IDF0, they just say there is a resource, but you cannot go into the resource.
Right. Yeah.
And what we do here is that we say, okay, pressing forces out of range. Okay, this is the processing. And then we go back and we could go into a lot of detail regarding the systems here.
Mhm.
And you can see this also in the tutorial that you used for the Bhopal incident. There we went into the system details.
Yeah. Correct. Yes.
Okay, I hope you're taking some useful notes, because I'm just saying a lot. I'm not
Yeah.
writing a lot.
No, I'm taking notes. I'm actually
Okay,
taking
great.
notes.
Good. So that's actually for me the most important what I wanted to say about what you should do.
Okay. So I
Let's see
would.
what else we have here. We have here the role of the supervisor. Yeah, this is also maybe an important part. You also have this in the tutorial at the end. Here you have the role of the supervisor, maybe a quality manager,
Mhm.
who thinks what kind of guidance would be important at runtime to improve the human machine performance here.
Okay.
So
Um.
they make they make the analysis about this the socio-technical system here,
Mhm.
and they devise scenarios at what point in time is some guidance or some adaptation required.
So exactly, how do you can you give an example? Because you say at runtime, is it
Yeah.
more of looking at it escalated issues, looking at let's say dashboards to put it bluntly, how do you concretely give it an example here?
Now think about you make an IDF 0 or you make a process diagram, let's say.
Yeah.
Then you have a lot of paths that you can take. Like in a program, you can at runtime you can take a lot of combination of paths through the program. Okay. And you have to find out, okay, when do you get on a critical path towards an undesired outcome? And this is actually described here. You say this went well, and then that happened here. Okay? And then you say, now this is critical. And you say, because if I don't do this, then we may end up with a problem here.
Yeah.
And therefore you say, when we get to this here, the code, and then we come to here, then this should happen, yeah? And then you say, here, I have another system that warns the operator and instructs the operator what to do and gets a confirmation from the operator. And when this happens, then things should be good, yeah? And this is actually just a hypothesis. We don't know it.
Yeah.
But you could monitor it at runtime, and then you could at runtime see how often does this scenario happen and what happened then.
So he makes the decision that there's no system for. Also, what I'm trying to visualize the operator at work time. So he just monitors
The
things and he gets.
supervisor, you mean the supervisor or the operator?
Sorry. I'm talking about the supervisor. So he gets notifications, or he's actively himself looking at escalated issues, if we can call them like that, or he just looks at some temperature measurements or whatever, right? So he makes that decision himself.
Suppose, I mean, maybe it's the easiest, Solomon, if you think the supervisor here would be a quality manager.
Yeah.
And here the operator is responsible for one process, and on a shop floor you have probably 20 or 30 of these. But you have only one quality manager.
Right.
So the quality manager would be totally overwhelmed with just running around and doing things. So the quality manager thinks, also it collects data to analyze when do they need to intervene. And they want to understand when should they intervene. And so for the runtime, they have some monitoring in place that says, okay, if you get to this here, then make an escalation to the supervisor, then they get a warning and they go there.
So they are also like a program. I can think of them as a program, right? The operator, because he's responding to preset things.
It's actually the same like here, yeah. Maybe let's say the lower part of the figure, yeah. Let's say this would be like this process. We just go one level higher. And now the operator is this assembly process would be the green thing, and now the supervisor would be the operator here, yeah, and says, okay, how can machines help me to monitor all these processes and inform me what I need to know so that I in person can address everything that the software cannot address.
So the supervisor is also a human machine mixture, I guess.
Always. Today, I think we always have to think about human-machine teams.
Okay. So what I was thinking more like this, like the supervisor is the highest form of intelligence that a human possesses. That eventually that person, as a human, is capable of resolving this. So it couldn't be. Nobody else could have.
The supervisor is the central person who thinks about dozens of these processes.
Yeah.
And how to optimize this, and would be totally overwhelmed. Yes, if let's say 1950s, okay, then you would have one quality manager for 3 operators or so.
Yeah.
But now you have one quality manager for maybe 10 human machine teams. So they can generate so much data, they would be totally overwhelmed without machine support.
Yeah.
Okay. So what they need is kind of some support, yeah. This kind of assistance systems or guiding systems that is able to supervise 10 or 20 of these human machine teams.
Mhm, mhm, mhm. And
So
they bring
they can be,
their sorry.
yeah, so they should be alerted only very seldom.
Right. And they bring what they bring is their experience. Although not anybody could have done it. They couldn't have been replaced by some. You know what I'm
I
getting
think
at? Yeah.
they are responsible for, you said uncertainty, right?
Yeah.
They are responsible for understanding things that nobody else can understand and address, not the
Okay.
operators and not the machines.
Okay. Okay. Yeah.
Let's say something simple. Let's say you get new input materials here,
Yeah.
and they are of different quality than what you had before.
Mhm.
Nobody here can deal with this.
Mhm. Mhm.
They just see something is not working out and they alert the supervisor.
Yeah.
The supervisor is smart enough, they have to do some research and say, okay, could be problem of the input, and they have to measure the input.
Mhm. Mhm.
Or if they know, okay, we get some supply chain has changed and we get inputs from a new supplier, then
Mhm.
they need to proactively measure the input and see whether there's some variance.
Mhm. Mhm.
You see, so
Yeah.
they are really the ones that have to have the oversight and understand what the socio-technical system doesn't know.
Yeah. Yeah. Okay. Okay. Okay.
So they are really, as you said, the highest intelligence in this system.
Right. Right. The one that's not so easy to replace with.
Impossible.
Yeah. Yeah.
Really impossible.
Okay.
It's impossible because always you have something outside, whatever you model, yeah, you have something outside of the model.
Mhm.
And as long as your changes and variation stay within your model, you're fine.
Yeah.
And as soon as something new comes in, like a new product or new materials or new process variants, or now you come with agentic workflows, then they have to say, okay, what's the impact on my solution architecture here?
Mhm. Mhm. Mhm.
Let's take the example of agentic workflows. Let's say now suddenly this machine here works 20 times as fast as before and generates 20 times as much as data before.
Mhm.
Possibly it's overwhelming other components of the solution architecture that was not prepared to have so much information.
Mhm.
So what do you have to change? No?
Mm.
And this is something that the supervisor has to consider.
Yeah. Yeah. Yeah.
So
Right.
probably the supervisor will work together closely with the software architect who knows all these systems.
Right. Right. A
And
good.
that's why I think this is so good for your career, because now you're a software engineer and you work inside here. And now you will develop an understanding about the social technical system and how to improve this. And I think very few people in your environment have been thinking about this.
Right. I wonder if it would directly impact my career. I have to change jobs to make use of it, I suppose, because I'm just a front end developer at the moment. But I understand what you mean.
Yeah, but I think it's good that you're a front end developer now, but that doesn't mean you will be a front end developer in 10 years.
Yeah. Yeah. I'm actually dabbling into the backend also, but I'm in paper I'm called a front end developer. Yeah.
It's okay. Now, yeah, and I think whatever you do, front end or back end, if you understand the whole system, you can make better decisions.
Right. Right.
Because if somebody asks you to change the front end and you say, look, but this is totally wrong, we don't need to change the front end, but we need to change something in the process or with the operator or somewhere else,
Hmm.
then it's a whole different discussion.
Hmm. Indeed. Indeed. Yeah.
Okay, so we have the supervisor here. What else? The valuation is important. What's the cost and benefit? Yeah, we discussed
Yeah.
before the minute that you save. Yeah,
Yeah.
how do you translate this into cost?
Mm. Yeah. In terms of man hour, perhaps, and how much money per year
That's
could be saved.
possible, but if something just is not worked on for weeks, yeah, is this a problem or not? And I would argue in many ways that it's not a problem unless it makes you report late.
Right, right. Yeah. I mean, there are people who don't finish their theses for years, so it's not
Exactly.
necessary that they are
Exactly.
having issues with it.
Here is also one thing. So this asset network here,
Yeah.
this asset network is a boundary object. So it carries knowledge and data between the domain experts and the project owner and the tech team.
Mhm.
And it's also a coordination artifact. What does this mean? It means if you think about the Levelson argument, the theory is that problems occur if these models of the process of and the environment in the different systems and people diverge from the actual process and from each other.
Mhm.
And what they do is they try to find out what is the essence, this process model variables, where they say, for example, at the train, is the door open, closed, is it in the station, and so on.
Mhm.
But where does this process model come from? And this is not clear with the Levelson. I think they just talk with the domain expert, and at some point they just say, okay, we think this is most important.
Mhm.
But it's never validated really with an architecture here.
Mhm. Mhm. Mhm.
And what
Okay.
we do is that we make a very simple architecture like this. Yeah.
Mhm.
And then we can add the characteristics here that we need to explain the impact here.
Mhm.
And then we can use these variables and the runtime state to align everybody, because this is then your baseline, and you can compare the view of the different systems and people with this baseline.
Mhm. Mhm.
And you will find out that some of the systems just don't see part of this.
Right, right.
And then you as an architecture can say as an analyst, okay, is this a problem or is this okay?
Mhm.
And if you say it's a problem because they are not seeing important parts or they have a delay or something, and there's a drift between the model views that is important, then you have an input to say, okay, what do I have to do here? How
Okay.
how can I mitigate this problem?
Okay. Okay. Okay.
So what you need is you need to be able to have this model, and you need to be able to have a stakeholder view of this, and you need to be able to version this. And this is why this paper introduced the language,
Mm.
the assets, no? The asset network, for example.
Mhm. Yeah.
Why is this cool? Because before we just had a drawing, and now we have a structured language that you can in Git, for example, version, and you can combine model parts and so on.
Mhm. Mhm.
So this is
Yeah.
also a boundary object that relates the asset network as a drawing to
Yeah.
the software engineering side, also to the AI side, because this is a great input to orient an artificial intelligence.
Right, right, right,
So
right.
that's why it's a very, very important paper, and that's why I thought it's good for you to have it.
Right. Okay. Okay. So yeah, yeah, because especially because you can see the outcome, the outputs and the inputs clearly, and the disturbance, and yeah, those resources clearly. The what and yeah. So the main idea about the pan is that you can see the physical, if you can call it physical, the physical items that the
Yeah,
process runs on. So right.
let's say the real world, okay?
The real world, yeah.
The real world, and also what you have here is you have these markers. And what you can do almost for free is that you can convert the networks into a Neo4j cipher
Mhm,
uh,
mhm,
knowledge graph.
mhm, 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 mhm,
And here the markers you can use to represent the design time and runtime state of all these things.
mhm, mhm, mhm,
So for example, if you have validation to do, then you can use a to validate marker.
mhm.
And then you can, at the design time, run a query on the knowledge graph to see what aspects do I have to validate.
Okay, okay. Do
And
you
then
also?
feed this into a task, for example, the ticket, yeah.
So yeah, you can convert it into tickets that you could work on later. Do you foresee also for this thesis that there will be a Neo4j type of knowledge graph created
If
here,
you
or?
if you think it's important,
Mhm.
you can. I mean, it's really cheap. Yeah,
It is.
I just asked the AI to do it, and it was there. It was like it was it was like 5 lines to do.
Indeed, indeed.
But just a prompt as an expert for this and Neo4j and so on. Describe a knowledge graph. Yeah,
hmm
and then I said, and then put the data into it and give me the queries.
Okay, okay.
I mean, it's
Okay.
really it's a new time. Yes, I mean, if you would have been talking like a few years ago, I would say, no, don't think about it. If, be conscious with your time. And today I say, go on. This is 5 lines.
Yeah. I wonder how one is able to say I did this and I did that, though, when it's all I'm doing is just prompting it, you know?
No. That's exactly why you have to do this thesis, because I think it's all about this architecture, and it's all about the smartness in the viewpoint.
hmm
Because you, as the architect and the maker of the viewpoint, you say what knowledge do you really need to describe and combine over the life cycle
hmm
to achieve that, yeah? And then to make the prompt and so on. This is not so hard anymore.
Right, right. So creating that knowledge graph is actually what would have been an undifferentiated code. If you like,
No,
it's not the
it's a
important
step
part.
in the life cycle. It's a
Genau,
step in
genau.
the life cycle where you say, to validate this really, I have to have a knowledge graph, and I have to be able to check whether things are really connected and so on.
Yeah,
And I need it at runtime, so I can update the data, and that I can then also run as a Neo4j Cypher query.
right,
I can run these scenario things.
right. It's just another tool. It's not that important that you know it
No,
by heart.
no, not at all. I
Yeah.
just think that Neo4j is very handy for this.
hmm Okay, okay.
But I mean, in principle, if you say Neo4j is you don't want Neo4j in your final setup, but then you can easily use the scenarios to move it to any kind of technology that you have in your architecture.
Yeah, no, I think I would just choose the best that's most representative because the cost of making it is almost negligible. So yeah, it's not
Yeah,
important.
I think what I like about Neo4j Cypher is that it's easy to understand also for domain experts.
Right, right.
Also, because if you start with JSON, or if you start with something that is more software engineering, then
Yeah,
people say, aha, thanks that you showed it to me, and they will never look at it.
yeah, yeah, yeah.
Okay, so we have here the coordination artifact as the asset network.
Yeah.
So that. Then and then we have the supervisor again. Here, this is the supervisor operator loop in the tutorial.
hmm
So this is going to this is actually this is the life cycle of your solution.
Yeah, yeah.
Okay, because always things can change, and therefore you need to have some iteration in there.
hmm hmm And I should also model the humans, or the operators, or could be a validator, whatever, with a certain level of detail. For example, in my case, I added complacency, but you also mentioned that they have varying degrees of interest. For example, the validator doesn't really. It's not in his interest to care so much whether it's not in his pay grade to look for problems that is there, and the submitter is not interested in knowing
Yeah.
the validator's
Yeah.
viewpoint. He just wants to do it quickly.
Of course. Yeah, I'm with you. I think you have this here in the DSL as the stakeholder knowledge area.
Mhm. Right.
That
Yeah.
you see what is the stakeholder knowledgeable or interested about.
Mhm. Mhm.
And you then can say, okay, they know about certain assets and they know about certain conditions, and that's what is their interest, and the rest they don't know.
Mhm. Mhm. Okay. Okay.
And I think that for you, I mean, you could model a lot of things, but it will get complicated and fuzzy, right?
Mm.
I think that if you take a positive view of the operator, you can describe capabilities
Mhm.
and you can describe capacity.
Mhm. Mhm.
So how many tasks can they do in a certain time window?
Okay.
Because the problem here arises, I think, if the operator should do something where they don't have the capability,
Mhm.
and the problem arises if they are overwhelmed beyond their capacity.
Mhm. That's what you mean with a positive. So you don't want to see it from a um, how do you say, sinister point of view, like he has some malice viewpoints. You don't want to model that. That's just
No, I think
another
it's totally
category.
different work.
Yeah. Yeah. Okay. Okay.
I think you have done enough on your plate, really.
Okay. I think so too. I think you had one or two more points.
So what do we have here? So a good result of the thesis could be method on analyzing and improving the solution architecture. And here then I looked up here what you could use as a architecture frameworks. You could start with the simplest, I think Grufton's 4+1 view. That's very established and old.
Mm-hmm, mm-hmm,
And very simple is the C4 architecture notation.
mm-hmm. I don't know this,
This
but
would
I
be
will
the
read it.
simplest starting points from my point of view, and they should fit very well to your software engineering background.
Okay, 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 okay. Yeah, I will read about this because I'm not familiar about this.
No, don't worry, this is really simple for you. I would expect that you know this already, and if you're not sure, you can always come back to me.
Okay, okay, okay. So
Okay.
I will prepare everything now that we discussed and show you again what I understood. And yeah, maybe it will take me 1 or 2 or 3 days until I really
What
properly format
I
it.
found, Solomon, this is also something that's maybe it's a bit of a style of um, how to represent your knowledge. Yeah. Now with the AI,
Yeah,
I think that it is very fast to make a lot of structured text.
yeah.
And I think this is not bad, but it's also the danger is to overwhelm the reader with too much text.
Okay, okay.
Okay. And I think what you should consider also is we talked a lot here now about one figure, right?
Mhm,
I think what you should consider is what are your core figures that should also go into your thesis later,
mhm, mhm.
and where are these figures much better to represent the ideas than a lot of structured text, because then you can have less structured text, also not less structure, but you have a less amount of text,
Mhm.
and you can anchor it in a figure.
Okay, okay, okay.
So, for example, you could redraw this figure,
Mhm, mhm,
just saying here we have here the process, then we have here these human machine teams. We don't have production systems, but we have something else. What do we have here?
mhm.
Then we have probably not just one operator and so on, but we have several.
Right.
And then we have here something with not an assistance system, but this is supervisor guidance system or something, right?
Mhm, mhm.
And then you would have these three layers, and in these three layers, you would have different possible variants. What could you have? So you have this degree of automation here, possibly different kinds of systems.
Yeah.
And then this would be your core figure to explain certain principles, let's say.
Mhm.
And then you could make a copy of this figure and instantiate it in your with your use case.
Mhm. Mhm. Okay.
Yeah,
Okay.
if you say, for example, the operator would be in the repository the validator, yeah,
Mhm.
and
Mhm.
here this would be a database or something. I don't know what they have now, right?
Yeah. Yeah.
And then if you want to show a more automated version of your use case, you would still have the validator, but some part of their function would have shifted to an agentic system, right?
Yeah. Okay. Yeah. Yeah. Yeah.
And it would be very important that you can show in the figure the similarities and differences between the solution variants.
Mhm. Mhm.
Because usually people and you will look at side by side at two variants and they want to quickly understand what is similar and what is different.
Right. Right.
For example, if you would have on the left side a traditional solution architecture and on the right side an agentic one, okay, what's the same and what is different?
Mhm. Mhm. Okay. Okay.
Yeah, and then I think that half a page of structured text could be very, very interesting. Whereas if you don't show the figure, yeah,
Mhm.
and you describe the figure on a page, and then you describe write 2 pages more about something that people have to make a mental picture they don't see.
Yeah. 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 Okay.
Much
Okay.
more difficult.
Yeah, and I guess this also ties to the way. How did you say the mouse? What was it again?
Send with the
The
mouse or
yeah,
make a
like
stick.
yeah, those. I think that you wanted to say the same thing here. I guess so that captures without too much text what the user needs to know about the system. And
Naja, that's one aspect, but by sending with the mouse, the aspect is you always, when you communicate, you always have two levels of people you communicate with. You have the people who have no idea what you're talking about before,
yeah,
the children, the non-experts, and so on. And they should easily learn something with even limited means to know what you do.
hmm
And you have the experts, like the two of us now. I know quite well what you want to do, right?
yeah,
And for me, it would be also interesting. So you always have to address both levels so that the first comes something that the child understands
hmm
and says, aha, this is how it is. And then
hmm
comes something for the expert.
okay, okay, okay,
But the
okay,
use case must be the same for both, right? And
hmm
the figures must be the same for both. Or
hmm
or if this is not possible, first you have to have the figure for the child
hmm
and then for the expert. Because if you put the expert figure first, then the child is lost.
yeah, yeah, yeah. I think I understand you now. The next document I will send you will be the way you explained it now. It's not a lot
Now
of.
the problem is always that people forget that they were once non-experts, because
Yeah,
when you read, then you become an expert, and then your mental model is different from before,
yeah,
and then you
yeah,
communicate as an expert to experts, and this is only half the story.
yeah, yeah, yeah. True, true.
Because all your if you want to later in your life, right, you want others to work with you and you need money and so on, and you will 99% of the time have to deal with non-experts.
Yeah, yeah,
Also they are not stupid, but they are non-experts in what you want to
yeah.
discuss with them.
Layman to the topic.
Now, yeah, it's the same if you look at this figure one here, right?
Yeah,
This works well because it's easy to explain.
yeah, yeah. Indeed, indeed.
Yeah,
Yeah,
and that's something like you need it.
yeah,
And if you look at the research literature, oftentimes they make the mistake to make very complicated expert figures.
yeah,
And then as a reader, you say, oof, I don't understand it.
yeah,
And then you cannot take up the interesting part.
yeah.
And you
Then
will spend a significant time to write the thesis, and the thesis and the presentation should be good to understand for everybody you meet.
right.
I mean,
And
in principle, it should be understandable for your family and your friends.
yeah, right. I mean, in my case, it also ties into the use of AI that you mentioned. That in this
Mm-hmm.
case, I have used the AI to go through papers. So instead of reading everything,
Yeah.
really helps me to like summarize it and go through the important parts. Maybe ask it which part should I actually read it verbatim, and then it could suggest this is
And with you,
this.
I think that, yeah, that this is a good point that you mentioned this. So I think that the AI will enable you to go much faster through a lot of materials. Yeah.
Yeah.
But the danger is that the AI has a subtle misunderstanding, or they are going somewhere where you don't want them to go.
Yeah.
And so you always have to validate. So what I would do is, and I put this into the, I gave you this workspace, right?
Yes,
Let me see.
but
So
it's
we have
empty
this,
currently.
here's the workspace from, where is it? I have to check this.
Okay.
But I sent you something about the work, and I
Yes,
think
the
this
first
should
one
be
is I need to create something
here.
because it's empty.
Here we have something. Do you see this?
Yes, I see it.
Can you access this page?
Mhm. 1 second. I just have to refresh it because it was empty last time. Uh, 1 second, I have to log in. I have to log in with my two-factor authentication, which takes a second.
So you should be I don't have your let's check this.
I still see page not found actually.
Yeah, that's why we talk about it, right? So what is your name at the Uvin?
Solomon dot Kahasai.
Wait. Let me Solomon. Also, yeah, I have to check this here. So Solomon Kashai, I have you here.
Yeah, dot
Okay,
Kahasai.
I edit you. I don't know how fast this is, of course.
Yeah, I don't know if they have a. It's like a Kafka
But
thing.
now I edit you, which is good, yeah?
Yeah, I see it now. I have it.
That's good. That
Yeah,
was quick. Okay,
yeah,
great. So, and the important point here is here you see it in bold, AI-based method for project proposal.
hmm
That's one thing, because I think you have still to write the proposal for the master thesis.
yes, and they have a new format, I think.
Yeah.
Mm.
So that page should help you with this.
Yeah.
So, okay, great. And then you have below, you see it here, you have the research design.
hmm
Maybe look whether you can access that.
I can access it. I can access it.
Yeah. And here the key thing is here do you see this here? Literature survey with AI support.
Yes.
Open this please and read it. I'll be back in a minute. And
Okay,
then we discuss it.
okay.
Good. So this is actually pretty cool.
Yeah.
So it's about how do you do the research analysis, literature analysis with AI.
Right.
So the first is you set up a workspace and the LLMs. Okay, let's just assume you have it, right?
Mhm. Mhm.
Then you have to think, what do you want to know about?
Mhm.
Like here you have some example template. You work with an LLM to find out more about it, the concepts, yeah?
Mhm. Mhm.
And you get a lot of ideas then, but this is not scientific.
Yeah.
And then you select the concepts that are interesting. So you should not have a lot, but the focus, yeah. And then you go to Google Scholar Labs.
Mhm.
Have you worked with this before?
Yeah, at the beginning, but I forgot it. Like when I was starting with my previous thesis, I did, but it's been a long time
Yeah.
now.
So, okay, that's very useful, okay, because you
Mhm.
can very quickly find real scientific works from this.
Mhm.
And then you select, let's say, 10 to 20 or 30 of these, and then you go to Google Notebook LM, now Gemini Notebook LM,
Mhm.
or the TU internal AI. You should have access to this.
Mhm.
Check this, yeah, whether you have access to this, and then you can really just look at the scientific works that you are interested in and make an analysis. And then you are on a good way, I would say.
Mhm. Mhm.
And then you can identify small portions of the material that you really need to read yourself.
Mhm. 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 Ah, so okay. Okay. Okay.
But it's really much better because in an afternoon you can do the work that took 2 to 4 weeks before.
Right. Right. But this also helps in documenting how I use the AI because that's part of the requirement for the thesis, right? I need to document
Yeah, of course.
what prompts I used and what I got, and yeah.
Yeah,
So.
what is important is you want the detailed prompts and so on. Yeah, that's nice. Yeah, but more important, it's important that you describe the strategy. How do you use AI? Yeah,
Mhm. Mhm.
what
Okay.
worked well, what did not work.
Mhm. Mhm. Okay. Okay. And this is all through a chatbot, I guess. It's not using a terminal-based AI that uses a harness and so on, right? This is all chatbots opening different tabs and so on.
Yeah.
Okay.
I think mostly, I think in the TU internal AI you can choose.
Okay. Yeah, I've
That's
never
why I
actually.
think that you should check the TU internal AI. I think as an employee of TU Wien, you should have access.
Yeah. To
If
be
you
honest,
don't, let me know.
I'm looking at it now. I have access, but I haven't used it before. This is the first time I'm using it.
Okay, but this is really, I mean, if you're talking about agentic workflows, this is your
Mhm.
environment
Okay. Okay. Okay.
because this has the access, the TU internal access to data.
Mm-hmm. Indeed. Indeed. Yeah. Yeah. That's actually important. Yeah.
Mhm.
Regardless of how
Yeah,
smart it is.
and then from these scientific curated materials, you can then go and write some text for your thesis.
Okay. Okay.
But again, also make sure that you have that you also draw the important figures,
Mm-hmm. Mm-hmm.
because I think that the LLMs are good at figures.
They're horrible. I tried. It's
Yeah,
really
they're
not
not.
good.
No,
Yeah.
you will. So what I do is I use Draw.io
Yeah.
because you have collaborative drawing with this.
Mm-hmm.
And in Draw.io, I make the figures, and then, or other people do it in PowerPoint. I don't
Mm-hmm.
care. Yeah.
Mm-hmm.
But it's important that you as a human think how do you communicate the essence, and then of course you can use this figure to inform the AI.
Right. Right. But I wish there was a possibility of commanding draw or IO from the AI itself, so I don't have to um, like draw the arrows because they really do take
And
some
I
time.
know, I know, I know, I know. But I've seen what people do, And I think the outcome is so much worse than what the human would do.
I tried, yes. It doesn't work. Yeah.
No, yeah, I mean, feel free to research this. I'm not against it, but I'll judge your output by the quality of your output, not how you do it, right?
Yeah.
So
Yeah.
if you make something that is shit, then I will tell you it's shit, and not I don't care whether you made it with AI or not. So I will usually not say it this way, but you know,
Will come.
yeah, it's important.
Yeah.
I think it's important that you get some useful feedback.
Yeah. Indeed.
Yeah,
Yeah.
okay, great. What's next?
Yeah. So, do you want to already set up an appointment for the next meeting, or
Yeah,
uh,
sure. This is very important.
right? So this requires this drawing stuff. I need to make some research. I need to look at two more
I'll be
examples.
away. I will be away until the 22nd, so we can start thinking about 24th onwards.
Yes, in that case, oh, 20. That last week of this month is actually not good for me because even more guests are coming to visit the baby. So, is it possible if we could do it the next month then, in September, the beginning of
September.
September?
Almost. I will be away in the first week of September.
Hmm.
So I think the sweet spot would be the 30, what, 30, 31st
Of August.
of August, yeah, because it's
Okay.
this week, yeah.
Yeah. That I think 31st of August is also okay. Let me just quickly check it. Uh, yeah.
So
No,
is the morning.
in the morning it's not good because I have a doctor's appointment actually on that.
What does this mean?
Could we do it in the afternoon? If you have time. On the
Um,
31st?
yeah, we could do it at 12 maybe.
The appointment is until 11. Yes, I think I will make it on 12, yes.
Let's try, yeah, and if it
Okay.
doesn't work, we can still shift it.
Okay. Okay. I will add it. But
Okay.
before that, I might send you my findings, my paper before.
You
Doesn't have
can
to be.
always send me something.
Yeah. So maybe it's even possible that this is just a meeting that you can give me the feedback or before already. So yeah.
I'll be happy. And if you send something to Christoph, please note that he has no idea what you're doing. So please send something that is Ethereum with the mouse is for a child. Yeah.
Okay. Okay. Okay.
He
Okay.
spent like 2 minutes reading this, and whatever he gets across in those 2 minutes is what he will think.
Okay. 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 I will do that.
So he will not read a lot.
Mm-hmm. Mm-hmm.
And
Okay.
I think we should not bother him before we have not. I think the next step would be the proposal.
Mm-hmm. Right.
Here, check the draft and master thesis proposal. Here I gave you some pointers,
Mm-hmm.
and then we take it from there. What do you take away from our meeting today? That would be most interesting for me to know now. What are the most important things
I think the most important thing
that
is
you
to
learned today and what you think we should do in the future?
right. So the most important thing is that I was delving too much into the details of the repository, which wasn't correct. I
Okay.
should yeah, I should focus more on the abstract, the general perspective of this model. And the other thing is that when I prepare this document, I should really focus on, instead of a lot of word salad like the first one was or the last one was,
Hmm.
put more effort into the figures and make it as focused and understandable, yeah, to the reader with the with the use of left and right or explanatory figures, more figures and a small amount of text that discusses what's going on. I think,
Mhm.
yeah, if I was able to focus or spend a lot of time on the figure, that actually requires a lot of thought and preparation, because that
Also
you can
I
talk.
think now that we talk about this, if you
Yeah,
find a clever way to adapt this figure one,
yeah,
I think then you have already done a lot.
yeah, yeah. Okay, okay. Yeah, because I
Because I
would.
think here you can do the architecture structure. You can somewhere put in where's the agentic workflow.
Mhm,
You can put in here the shift that we discussed from the operator function to the machine function.
mhm, mhm.
You can put in the coordination needs between the operator machine and several human machine teams, and okay, missing here is the supervisor.
Yeah,
This is maybe one thing that I wanted also to say to you. Who are the most important stakeholders in your work here, right?
right.
Also one is the sponsor,
Yeah,
because the sponsor is the reason that this project exists at all.
yeah, yeah,
And the second is your personal role as an analyst. I mean, your role here is now also from the perspective of the sponsor, you are a consultant,
yeah.
you are an analyst. Also you talk briefly with them and with domain experts, and then you go away and make clever things and come up with a cool analysis and proposal how to make things better.
Right.
Then we have the role of course, of the operator here.
Yeah,
Also somebody who is an executive role, let's say.
yeah.
Then we
So.
have the role of the quality manager, the
Mhm,
supervisor.
mhm.
This you have to find out. Possibly
Right.
it's missing in many use cases.
Mhm, mhm.
It's also an operative role, but also has some design power. Yeah.
Mhm, mhm.
And then I think in many cases, thinking about the repository domain similar cases, you will need software changes. And that means you have to have then a product owner and a tech team.
Yeah, yeah,
And
yeah.
as the analyst, you're also the solution architect, I would say.
Right, right, right.
So this would
So,
be, from my perspective, 4 to 6 roles that you need to consider.
right. And if I could just focus on this figure and different variations of it, that would
Yeah,
already suffice then, I guess, right? Yeah.
I cannot say it finally, but I think it would at least 2/3.
Okay, okay, okay.
Now, because what you see here is this control system view from the Levelson side, okay?
Mhm.
And possibly you will need to have something from the Vocando side too. But this is what
Right,
we need to find out. I
right.
think the weakness of this control system view
Mhm.
is that it's missing the actual architecture view.
Right, right, right.
It's a logical functional view, what they say, yeah, and that's right, and it's good, it's abstract, that's why it's very useful, but it's not a link to reality.
Yeah, 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 yeah.
And what they also not have is this impact path from the, and they don't have the scenarios. So,
There's no
also,
escaping it.
so this you can tell 2/3 of the story with it,
Yeah,
and then you have to explain why do you need the rest.
yeah, yeah, yeah.
Because I think of course you can work with this, because the Levelson group has worked for 12, 20 years with it.
Mhm, mhm.
But I
Yeah,
think that it works. This works well in an expert environment, but it does not work well to communicate with domain experts who are not
yeah,
modeling experts.
yeah, yeah, yeah. Doesn't go low enough to the abstraction is not low enough.
it's not, they're not trying to connect to to domain experts.
Yeah.
And for them, so if you look at you're reading the profile, so I think they've just been doing a lot of going through text and so on.
Yeah.
I mean, the good thing is that an AI can help you with this, but how do you validate it?
Yeah, that's true. Yeah.
So I think that the contribution of the Vocando is that it's easier to validate.
It's true. Yeah.
Mm. Na gut,
Yeah.
okay, what else do you take away from today?
What else? So, yeah, I mean, we saw some of the limitations of the operator, and then, I mean, restated the human machine interface, also the
Yeah.
human machine work group, and that this also belongs in any stage actually, including the supervisor. This was something that I mean, it should have been obvious to me, but of course, it's like that.
Yeah.
Yeah, and that this green layer that you see here, the assembly process, clearly maps into the IDF0 part,
Yeah.
and this, yeah, I mean, it's just another view of the model. Um, yeah, and what was the other one? There was one more important thing that I noticed. Uh, yeah. I mean, indeed, the share of the work done by a human and by the machine
Yeah.
part is always shifting. You could mod.
It's a question of capability and capacity.
Genau, so you can always model it the way you like. So, like the car self-driving example was a very good one, because depending on the level, you can always decide how much the user, that also the human, is involved, and so on, which naturally maps into.
Exactly. Now that we are talking about this, I think what is new here is that traditional systems, like you see it here in the picture,
Yeah.
you have a controller with sensors, actuators, and the controller is actually a deterministic program.
Yeah.
And the uncertainty comes from the sensor, the data, and so on, right? Which is a bit uncertain. The outside is uncertain.
Yeah.
And as soon as you introduce AI functions, like also the agentic workflows,
Yeah.
I think you also have to discern where does uncertainty and stochasticity and things that are not reproducible come in.
Yeah, but one of my questions earlier was very much well, more philosophical, I guess, because if you replace the AI with the human, why is the human not treated with the same level of skepticism that an AI is treated with regarding uncertainty? Because both of them are vulnerable to the stochastic nature of their decisions.
But the thing is, I think there's more experience with the degree of human capability and stupidity than with AI.
Okay. So it's just
Yeah,
a matter of that we know about the human and we can predict it
yeah.
as a result.
Suppose you ask somebody to make an important job for you,
Yeah.
and somebody comes in through the door, you don't know them, yeah? Then with the human, you would ask them whether they understand certain concepts, and you would let them do the job a few times and see, okay, do you do it correctly? And you would tell them, okay, if there comes something new that you don't understand, please let me know.
Yeah.
And then you would say, okay, I've seen he does the basic stuff correctly, and I think he will come back to me if something is not clear to them, right?
Mm-hmm.
But with the AI, this doesn't happen. They always give you something, yeah, and sometimes it's surprisingly good,
Yeah.
and sometimes it's surprisingly bad. And I think this totally surprisingly bad you don't have with the human. And the problem with the AI is it's an automated machine, so it's very efficient at making waste
Mm-hmm. Yeah. Okay. That actually makes a lot of sense. Yes.
and very silent.
runaway is the word, I guess, right? That you can have a runaway bud, whereas the human cannot produce so much bud at one point and in
Exactly.
one go. Yeah,
Yeah, and you will notice somehow.
yeah, yeah,
And
yeah.
today, people trust too much in the AI, and it's not. And I don't even say hallucination, but I think that very subtle quality things can go wrong, and you just don't see it.
Yeah. I mean, ultimately, unless you check it yourself, maybe it's a recipe for disaster, yeah,
And that's
regardless.
why I think that in our example, I think that the distinction between the safety and the functional layer is very important.
Yes, yes, yes. So that's the other part. Yes.
Because I
Um,
think that what you could argue that the safety part must be rules that are deterministic.
hmm. Yeah, 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 yeah. Yes, indeed.
And what
Like you might have a checker code. For example, you might have some script, a Python script that is triggered by a hook. So the moment some processing is done by the AI, it
Mhm,
cannot. And I tried this. It cannot, even if you asked it, it cannot do it. If you put this harness guardrail of a hook,
mhm, yeah,
it would say I'm not allowed because the hook doesn't let me. And I even asked it, but I'm telling you to do this, and it says no, I can't unless you override that hook, like remove it by hand yourself. He can't.
okay,
And this could be an example of a guardrail. And the next thing is that not only that you have the hook, but what do you use the hook for? Maybe you have a script that checks the output deterministically. So but these are all attempts to put um, protection around it. You know, but I don't know if this is also how our brains work. That we have all
yeah.
these
This is
layers
no,
of
this is exactly how it should be because people will just trust in the guardrails, they will not trust in the AI.
yeah. Yeah, exactly. Because there are instances when I tried it also that it didn't work. So I used another model, and apparently there's a system prompt inside this model that just doesn't care about your harness. You know, it just skipped it. So that was very
Yeah,
surprising and very alarming actually that it was able to do that.
yeah,
Yeah,
yeah. But this is exactly what has to go into your thesis because this is a core architecture question.
yeah,
What can you safely do? Yeah, and I think if you cannot ensure that you can have some safety checks, then I think you cannot use it.
yeah, yeah, yeah. I mean, one error is too many for for this solution because like you said, it's a runaway and can produce so much bud at once.
Yeah, yeah,
Yeah, that's the problem.
yeah, yeah. Now, yeah, if you think process undesired outcome, what
Yeah,
can go wrong, and on what level can it go wrong?
yeah, yeah, yeah. How much damage can it produces would be I think that should be part of the discussion in the thesis too, right? Like if things do go wrong, just exactly what is the upper maximum limit of bud that could happen, or at least an
Exactly,
analysis of it. Yeah, then you
exactly. And
know.
and you have to think in a realistic time window, let's say a workday or so, yeah.
Yeah.
And how does a safety net have to work with this?
Hmm. And how could it catch it and so on.
Good. Okay. What would be for you the most interesting that could come out of the thesis?
Um, something that shows people that um, you could use the AI. I think that's. I mean, I'm talking very generically, I guess, but that you could use it, but with these constraints, or that you could use the AI, but with this caveat. So you know, like it's not good or bad. There's a way to. Ultimately, these things are useful, but you need to know how to use them, or maybe something in this area of in this vibe, let's say.
Okay. So I'm with you. Considering the role of the solution architect with the socio-technical environment, yeah.
Yeah.
And you need to educate the product owner and the software technology team
Right. Right.
because they don't look at this.
Yes, because it's either or for most people. It's either all bad, they just don't trust it, or they are stuck with the image in their heads of what the systems were doing 2-3 years ago, and they don't know the capacity of today. Or also
Yeah.
they know that they are really fascinated by what's happening, but they don't see the danger. So it's
Yeah.
usually or that they don't. Let's say the idea is to bring the subtlety of usage, or I don't know. This is just
Realism, let's say.
realism. Yeah, yeah,
Yeah, and what is more is that the software technology people will just oftentimes only look at the software and their own frame,
yeah.
and will just ignore a lot of the environment.
Right, right.
They don't understand it and they don't see it as their responsibility. And therefore, you as the solution architect must explain what is their responsibility.
Exactly. Yeah, yeah, yeah. Yeah, and
Okay.
also, I mean, um, they're saying things like it's possible that this is not making business sense because they're burning a lot of money. We are using all this AI, nice AI, because of VC money. And it's just flowing, and they're burning through it.
Yeah.
It's possible that we are not going to use it, so it's a little bit of a strange time. I think right now because they're waking up to that the investors are not getting their money back. So it's possible that this thing is also gone after a while, because they can't really bear the cost of the inference anymore. And yeah,
In fact, yeah.
it needs to make business sense for them too. And currently it's not. So I don't know where the direction is also.
I think they will not be able to give it away for free for long.
Yeah, because we are essentially using it for free apparently because it's heavily subsidized. Whatever subscription fee or even tokenized. I think the token people who pay for the token, so the API, I think they're paying the real price. But the people who are using subscriptions it's totally subsidized, so it's not the real price. So
Yeah,
it might come to an end also, or at least the good models might come to an end. Yeah,
I think they will kind of, yeah, as you said.
yeah,
Na
yeah,
gut, but this is actually independent of what we say today.
yeah, yeah, yeah,
But
yeah.
I think the simple agentic workflows that we're talking about, I think this should be maybe you can have this is actually a good point for different levels, yeah.
Yeah. So maybe the solution, if there is a solution that's actually being built, could be built with open source agnostic as possible agent. So zum Beispiel the Pi agent. This is an Austrian guy who made this actually, a coding agent that doesn't care about. It is like Cloud Code, for example, but it's totally open, and you can do it. You can specify extensions and so on yourself. And if you could run your own, however weak that might be actually, but if you could run your own models, then you're totally free. I guess you're not dependent on some American.
But then it would be interesting to know what is the capability and what is the cost of this.
Yes, yeah. That I mean that would be a natural question. Yes, of course. And also,
I mean, you
if
don't
we,
have to don't you don't have to solve all of this, but I think it would be interesting if you're talking about agentic workflow.
yeah,
How much power do you need for this?
yeah, yeah, yeah. And how much does it cost to
Yeah,
run it? Yeah, yeah,
if you do it TU internally, I think that would be interesting, and we could measure this probably.
yeah, yeah.
Um, and but externally, I want to know. I mean, if I run, what's the relation to, let's say, run a search query, yeah,
Yeah.
on a search engine, to simple AI to advanced AI.
Right, 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 right.
Do you
Yeah.
know anything about the relations? Is it magnitudes or just a little more? Or
Um,
we just don't know.
I don't know exactly to be honest, but I do know when you do specify harnesses, for example, it allows you to choose the model. So if you have like agents, like an orchestrator agent, and you have minion agents, smaller agents that just do a specific small task, you could always
Mhm.
specify in the file, in the MD file that the agent is reading, that it should use this model, and that model
I'm with you. You
usually.
can choose the model, but what
Yeah.
is the environmental impact, for example? How much energy does it take?
That I don't know. I don't know.
Now, can you maybe take a note? Maybe you can easily
Mhm.
find out at least something about this.
Okay. So depending on the model type or the major providers, what is the
Yeah,
relationship to power usage or the cost, at least
that
if
you,
it's.
yeah, exactly, that you have a baseline, something that we know and usually use, yeah, and
Yeah.
how much more expensive is it to use the AI stuff?
Yeah. Because this is important. It goes back to the feedback of is it worth it question, right? So.
Yeah, exactly. Now, is it worth it on the environmental and also always related to the cost, because if it will be related to the energy cost in the end.
Yeah.
Good.
Okay.
Thank you very much. So I think it's
Thank
a
you.
very interesting topic.
Yeah.
Maybe you compile after our meeting. I'll send you our meeting minutes. So you compile what you think about and what should go into the proposal. So for me, would be most interesting, what is your guiding figure for the proposal?
Hmm.
And what topics would you put into the proposal?
Okay.
Do you have examples for proposals, or do you need something?
If you could give me the more the better. I don't have any examples at the
You
moment.
don't have
Or
examples of it. Good. Then I'll send you examples as well.
okay.
Good.
Okay.
But there are different examples. Do you need one for a seminar, or do you need just to propose to the Dean of Studies?
Last time I did it is that I did it in the seminar. I don't know if that it was the same thing. I created a PowerPoint and there was a document part also, which I handed in.
Okay. Okay.
Yeah.
Do I
So
know this? Did you send this to me?
no, it was I never sent you. It was with Martin Kendler. It was from the statistics and economics faculty.
That
Uh,
means you already have the seminar. You don't need it anymore.
I suspect so. It's a mandatory participation, but I don't think I need it. But I will be there anyway because I have to present it anyway. So yeah,
Okay. Now, yeah,
I
the
think
question for me is, do we have to prepare something from the seminar with this current topic or not?
I suspect we should because everybody has to present his proposal as a presentation. If
Is
I'm
it?
not
Okay.
mistaken,
And
I don't
when
know.
is
This was my
when,
understanding before.
when is this due? Okay, find this out.
Okay. And they
This
have
is
like.
very important. Please survey the process, all the deliverables, external deliveries that we know about this and can plan for them, right?
Yeah. Okay. I will
That's your
I will
job.
do that.
I don't know
Yeah.
about it.
Okay.
I write it up here. This is that you have to uh, find out all external deliverables. Yeah, studied in. Yeah,
Okay. Hmm.
required to for project success.
Yeah.
That's very important. Okay, good. Great. I think other than that, we are done. Do you have
Okay.
other topics we should discuss?
I mean, I wish I could talk more, but I actually have to go and do an exam right now, a car theoretic exam that I have to pass. So I have to
Okay,
leave
great.
now, actually.
Great. So then let's not keep you any further.
Okay, and thank you.
Uh, yeah.
So I will discuss. I will send you what I did before the 31st, and we
Mhm.
meet on the 31st. Then.
Yeah, and soon I would like to see the summary, what you take away from our today's meeting. I send you the notes and you can extend them. Yes.
Okay. I will send that before, of course, like last time.
Right. Good luck
Yeah.
with your exam.
Okay. Thank you. Okay.
Bye bye.
Ciao. Bye bye.